Malia should be able to do it pretty good. Just not quite as good as Julie. One of three. Perfection. You're right. There were some others that also did, but you were tied with them. So no one was better than you. All right. Okay, so. All right, Zena, if Monica's going to stay there, you got to be quiet. All right. So, today we are looking at greatest common factors. So, what we're learning to do today and tomorrow, well, not tomorrow, Monday and for the next couple of days, is we're going to reverse what we have been doing. All right. So, let's just do one problem where we are distributing. So, we might do a problem that looks like this: 7x squared times 3x minus 1. Right? So, to simplify this, that says simplify, we would just distribute that x squared. Alright, so we would do 7x squared times 3x, and that would give us 21x to the third. And then we would do 7x squared times negative 1, so we'd have minus 7x squared. Okay, so we've already done this. We were just distributing. You guys were really doing pretty well with it whenever we did that, I think. So we're just multiplying. You guys even are doing where you actually multiply the binomials and do even more difficult stuff than this right here. So we did pretty well with that. So what we've got to do today is we've got to go backwards. And Mr. Brown had a good analogy the other day because we were talking about factoring, because Coach Wood and I are both factoring right now. And factoring is something you're going to do in all of your classes for the rest of your mathematical career. We're still factoring in calculus on a daily basis. So this is one of those. There are some things that we do that if you don't get it, you might still be okay in the next classes. For example, rational exponents. They're going to come back up again sometimes where we have to write those roots with the fractional exponents. They're going to come back up again. But if you never get that, you're probably not going to fail Math 2 because of it. If you can't factor, you might fail Math 2 because of it. Because this is one that's it goes through all of your classes that you're going to have to be able to do this. But the good news is it's not terribly difficult. However, Coach Brown said that multiplying is like driving into your driveway forwards. And factoring is like backing out of the driveway. And backing out of the driveway, it's not that hard, but it's a little bit harder. And you might run into your mailbox whenever you're going backwards. So it takes a little bit more to do this than it does multiplying, but they're related. So it's sort of the same thing. We're just kind of driving backwards here. So this is what type of problems you're going to see. Okay, so we're going to call this example 1 because this is the first one that's actually factoring. It is going to say factor. And you're going to have something like 3x to the third minus 18x. Okay, so what they're doing here is they're giving you, like the multiplying problems, they're giving you the answer. And they're wanting you to go backwards to the question. Okay? Kind of. So, what we're doing is we're trying to factor something out. And right now, it's not going to make really sense why you would want to go backwards. But we are eventually going to get to the point where we're using this to solve quadratics and do things like that. And so when we're doing that, we'll be able to solve equations that we couldn't solve otherwise. So it does have a purpose, but we've got to learn how to do all of this stuff first before it's going to have a purpose. So we want to think the opposite of multiplying is dividing, right? So we want to think of a greatest common factor. What is the biggest thing we could divide this by, and it would go evenly into both terms. So we could divide both terms by 3. All right, let's also think about the variables. Okay, I've got 3 x's here, but only 1 here. So I could divide by the lowest exponent that I have. So I could divide by that x to the first power. So if I do that, I would write my 3x out here, out front. It is, isn't it? I would fix it, but it messes up other stuff. Which one is it? Okay, there we go. That's better, right? Okay, so now you're not questioning whether or not you might have a brain injury. Do you ever think that? Like whenever something looks blurry, you think maybe you've gone crazy, maybe have brain problems. But everybody else is seeing it, so you're fine. All right, so here, 3 divided by 3 is 1. It goes away. You've got x to the third over x. So you would subtract those exponents. 3 minus 1 gives you 2. So you get x squared right here. And then here, 18 divided by 3 is 6. So we get a minus 6. The x over x, that is just going to cancel out. It will just be a 1, so it goes away right there. So this is our answer if our instructions told us to factor. Okay? And we can check these really easily. To check, you just multiply it back and see if you get what you started with. So if we multiplied this back, 3x times x to the third is 3x to the third, and 3x times 6 is negative 18x. Now, it might seem, why in the world do we have to do this? Eventually, I'm going to teach you about the zero product property, and it's going to help us solve equations that we couldn't solve before. But for right now, we've just got to know how to factor. Okay? All right, so this tells us we're right. This is our answer. Okay, questions? They just got me a new projector. I think it's something about this program. It doesn't like to cooperate. I do need to go to the eye doctor. All right, let's try this one. 8x squared y to the third minus 12x y squared. This is still, all of these will be factor. I didn't write it, but they're all factoring. All right, this time I've got 2 variables. But what I'm going to do is I'm going to treat each piece separate. So I'm going to think first of 8 and 12. What number could I divide 8 and 12 evenly by? 4, right? So I'm going to divide both of these by 4. Means I'll have a 4 out front. Then think of the x's. I've got x squared and x. I could just divide by just the x there. And then I've got y to the third and y squared. Okay? Y to the second. So it's always your lowest exponents that you're going to use for each variable. So I'll have 4x squared y to the second will be out front. 8 divided by 4 is 2. X squared divided by x is just x. 3 minus 2 here, I just get y to the first. And then for my 12, 12 divided by 4 is 3. X over x cancels. Y squared over y squared cancels, so I just have a 3 there. You can always check by multiplying this back. 8xy to the second times 2xy would be 8x squared y to the third. And then 3 times 4xy squared would be 12xy squared, which is what we have. Okay, questions? All right, let's try another one. There's a few more tricks I need to show you. What about if we have one that looks like this? 9x squared minus 27x plus 81. All right, so what could I divide all those by? 3 would work, but 9's better because it's bigger. 9 will go into all those. What about my x's? Can't do the x's at all. You cannot do the x's at all. Does 81 have an x with it? It does not. So if you're dividing by x, you have to divide every single term by x, and 81 does not have an x at all. So you cannot divide by x here. So the only greatest common factor you have is just that number, and you're going to leave the variables alone. So you'll have the 9 will be out front, and then you'll have x squared minus 3x plus 9. You cannot divide by an x because it would work fine for the first 2 terms, but then if you did that over here, you'd have 81 over 9x, and so that would give you like 9 over x. You'd have an x in the denominator, and we don't want an x in the denominator. That creates a fraction. We don't want to have that. So if you have a constant term, we call that the constant term, the one that does not have an x with it, then you can't take any variables out. Only numbers will come out if you do that. Yes? That's a good question. Good question. So, for example, let's do one like that. Guys, we are taking some notes, so if you get out a sheet of paper, you can catch up where we're at, and you will probably be able to catch on to what we're doing. So get you a piece of paper. So, I'm going to give you a couple that will sort of answer that question, Evan. Okay, so example 4. So those of you guys that were just out working on classes, what we're trying to do, let me flip back just to let you guys see real quick. What we're trying to do is you have been multiplying. So you were doing like 7x squared times 3x minus 1. And you just distribute and you get 21x to the third minus 7x. Most of you were doing fairly well with that. Okay? So what we're doing now is we're going backwards. We're taking the sort of like the answer to that multiplication problem, and we're factoring out the greatest common factor. So we're going back to what the problem looks like. So like for example on this one, 3 and 18, I could divide both of those by 3, so I did. And I've got x to the third and x, so I could divide by my lowest exponent there, which was x, so I just had an x right there. So when I did that, I pulled the 3x out front, and then 3 divided by 3 was 1, x to the third divided by x was x squared, and then 18 divided by 3 was 6. The x's canceled. That gave me 3x times x squared minus 6. Now, this, if you multiply it back, gives you what you started with, so that lets you know that you factored it correctly. Okay, so that's the idea of what we're doing. So let's look at example 4. cannot, no. So, I'm going to answer that question two ways. First, let's look at example 4. Because do you have a number that will go into, there's not a number here, but it would be a 1. 1, 9, and 4. Now, other than 1, and 1 doesn't do anything, right? So nothing goes into that except for 1. So you don't have a coefficient that's the greatest common factor. But if you look at your x's on this one, do you have x's with every term? Yes. So you could, on one like this, where you don't have a greatest common factor for the numbers, you could still divide everything by x squared. So this is part of the answer to your question, Julie. So you would divide everything by x squared. That x squared would be out front. So you would be left with x squared minus 9x plus 4. Like this. Okay, Adam, write it down. Gabe, Tristan, write it down. Got it? Okay, good. Okay, so sometimes all you can pull out is the variable part. You cannot pull out a number to go with it. So that is part of the answer to your question. Then, because Mrs. Hyatt is mean and likes to trick children, that'd just be your answer, yeah. Because I'm mean and I like to trick children, and I just sit around coming up with problems to trick you, sometimes I'll give you something like this. 3x to the 4th minus 9x plus 7. Okay, 3, 9, and 7. Can we divide those by something? No, the 3 and 9 look pretty good until you get to the 7. There's nothing you can divide all those by. All right, what about x's? We also have this constant term over here that does not have an x with it. So Evan said 1. We could divide by 1. If we did, we just have 1 times 3x to the 4th minus 9x plus 7, which would be exactly the same thing, right? So I occasionally will put a problem like this mixed in with the rest of them, okay? And so the word that you're going to use for this is prime. Okay? Because a prime number cannot be divided evenly by anything except for 1 in itself. So a prime expression cannot be divided by anything but 1. You'll just say prime for those. Yeah. Yeah. Sometimes, yeah. Yeah, sometimes I might get, it's kind of like when I would give you one with exponents where it might be like 3x to the 4th minus 7 over 8x to the negative 1 times 4x to the negative 3 over y to the 4th to the 2nd to the 0. Okay, so I might like to give you questions like that look terrible, but what's the answer? It's just 1, because everything's raised to the 0 power. So I might do the same thing to you with the quadratic, with these expressions. I might give you a bad one, and then really it doesn't factor at all. Yeah, because I do like to try to trick you guys a little bit. We are. Okay, I'm going to do one more problem, and then we're going to do the worksheet. I don't like to trick you just to trick you. I mean, I do take you're right, I do take a little bit of joy in tricking you, a little bit, but mostly I like to trick you because if you have been tricked with something, hopefully you've learned your lesson and you don't fall for that trick again. So you've learned in this situation, I do this instead. So I like to try to trick you to keep you from being tricked again. Now, some people you can trick them with the same thing over and over and over again, like Henry. We're going to do one more sort of normal one. Let's see. Let's do one with a couple variables. 7a squared b to the fourth minus 28a to the third b squared plus 7a squared b squared. Easy. Okay? I heard Malia say 7s. Is that right? Okay, you can divide everything by 7. What else do you think, Evan? Okay, a squared, b squared. Because if you look at all your a's, your lowest exponent is 2. If you look at all your b's, your lowest exponent is 2. So we're going to write that 7a squared b squared out front. Don't forget to put that. A lot of students forget to write that part, but you got to write it. And then, so 7 divided by 7 is 1. A squared divided by a squared is 1. B to the fourth divided by b squared is just going to be b squared. Okay. And then 28 divided by 7, that's going to give us 4. A to the third divided by a squared, that's just going to give us a. B squareds cancel. What did I do with the last one? Okay, Evan says plus 1. Why do I even have to put plus 1? Seven divided by 7 is 1, right? A squared divided by a squared is 1. B squared divided by b squared is 1. Evan is correct. You do have to put a plus 1 there. A lot of students just cancel that out and don't put anything, which is not going to work. Because to check these, you have to be able to multiply it back, right? So if you don't put that 1, you're going to get 7a squared b to the fourth minus 28a to the third b squared. But if you don't put that 1, you don't get the last term, right? So you've got to put the 1, and if you do, that'll give you the 7a squared b squared so that you get exactly what you started with, and that is correct. Yes, Ian? Oh, yeah. Yeah. So, like, if I were to put this on the quiz, and you'll probably see one of these, and it had a multiple choice, one of the answer choices is going to be 7a squared b squared times b squared minus 4a. Right? That will be an answer choice because it's wrong, and it's a very common wrong answer. So that would be incorrect. So if you have terms that cancel out with this, you've got to put a 1 there. Okay? Yes. 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 I think. I'll have to check the answer key. All right. Questions? All right. Simple enough. You guys can do it. We're all going back out of the driveway without hitting the mailbox on this. Can't promise.